Okay, let's look at number 16, 17, and 18. Number 16, again, they're giving us a data set and they're asking us to calculate the mean, sample standard deviation, and population variance. Now, as far as the mean is concerned, you notice it doesn't say sample mean or population mean like it does for the other ones. Reason being, because it really doesn't make a difference in the calculation of the mean, whether it's the sample mean, which is the x bar, or whether it's the population mean, which is mu. They're both calculated using the command average. So unlike the standard deviation and variance, where you have the commands have a .s or a .p after them, meaning a .s means for the sample and .p for the population, the mean doesn't have that. So if I want to calculate the mean, whether it's sample mean or population mean, I just type average and I select the values in which I want to calculate the mean, and there's my mean, whether it's the population mean or the sample mean. Alright, so let's find the next one, sample standard deviation. Sample standard deviation is labeled as S. Population standard deviation would have been sigma. So sample standard deviation, I type stdev for the standard deviation command, and it's a sample, so I use .s for sample. And I select the values, press enter. And that's a sample standard deviation. In case you're wondering what would have been the population standard deviation if I would have used the stdev.p for population, and I would have selected these numbers, look at the answer. So you notice the answers aren't that different anyways. I mean, sample standard deviation is 11.8, population standard deviation is 11.4, so you look at it as a population. So anyhow, so that's that. Let me just erase it. Alright, and then they want us to calculate the population variance, which is var for the variance command, .p for population. And that's it. That's the population variance. And of course, when it comes to the number of decimal places, there's no general guideline on that. They usually say use one more than the highest number of decimal places. So if you look at this table, you notice that the highest number of decimal places belongs to 34.52, the 2 decimal places. So you know, officially they say you should have one more than that, so you should have 3 decimal places in the final answer. That's what research says. So that should be like the official, but this is not a research project, it's a class. So you'll be instructed on the exam as to how many decimal places to leave for the final answer. Alright, so let's move on to number 17. It wants us to calculate x bar, and again, x bar is the sample mean, but it doesn't matter whether it's sample mean or population mean. I just type the command average, select the numbers, there's my average. Calculate sigma squared, that's population variance, so it's var.p. So you have to know what these symbols mean. That's var.p. Mu, again, average. Doesn't make a difference for mu and x bar. Of course, it's going to be the same value. Same value, of course. Eta is the median, and again for median as well, whether it's a population median or sample median, the command is just median. So median and average don't matter whether it's a sample or population, they're both calculated the same way, they're just called different symbols, that's all. So there we go. That's eta, that's population median. And S, which is a sample standard deviation, stdev.s. And again, select the numbers, and there's your answer. And again, let's say go with the research rule when it says there's no decimal places, so the highest number of decimal places is 0, and one more than that is 1, so that means all my answers should have 1 decimal place. There you go. So officially those should be the answers. Alright, and then number 20, they're asking you to figure out, they're giving you a data set, and in this data set, is 97 a usual value or not? Now, again, based on the lecture notes, you know that in order for you to determine if a value is usual or not, all you have to do is find a z-score for that value, and if that z-score is within plus or minus 2 standard deviations away from the mean, in other words, if that z-score is between -2 and 2, then you conclude that that's a usual value. And if that number, the z-score you calculate, is less than -2 and greater than 2, then it's not a usual, then it's an unusual value. Alright, well, my x is 97. They've given me my x value. That's the one I'm trying to determine if that's usual or not. Well, in order for me to do that, I need to calculate the mean and the standard deviation. The mean is average, and my standard deviation now here, I could use stdev.p or stdev.s, population or sample. Here, let's just go with stdev dot. Let's treat this as a sample, and let's select the values, and there's the standard deviation. Now, in order to find the z-score, I have to do, and here's the formula, x minus mu over sigma, and you have to put x minus mu in parentheses, so x minus mu, close parentheses, divide by sigma, and there's your z-score. Now, just to let you know, because you're wondering, what if I didn't know I have to use .s, what if I use .p? Well, let me do it with .p, see if it makes a difference. So here, basically, let's just finalize our answer. Here is 1.6, so it's within plus or minus 2, so it's usual, right? If it was like 2.8, it would have been unusual, or negative 2.7, right? So if it's within minus 2 and 2, then it's usual. And if its z-score is 1.6, that means it's usual. Well, it's getting close to 2, so it's like it's a top grade, but it looks like it's still a usual value. Anyways, so that's that, and I just wanted to calculate it for you with the population command, just so you could see what there would be no difference. stdev, at least for this particular application. So if I calculate the population standard deviation, if I had calculated the population standard deviation, instead of 28.8, I'd have gotten 28.2, and then my z-score, the difference would have been x minus mu divided by, and instead of using this standard deviation, I'd use that standard deviation. You see, 1.6 is basically usual. So for all application, it doesn't matter really if you use the population standard deviation command or the sample standard deviation command. Really doesn't make a difference in this exercise.